Good morning, students. Let's start with a new chapter, Indices, Module 1. Practice set 26, question number 1. We have been given a table. We have to complete the table given below. Let's see what's given in the table. We have first column as serial number, second column, numbers in the index form, third column, base, fourth column, index, fifth column, multiplication form of the numbers given in the index form, and last column we have value. Let's see the first example. The numbers in the index form is expressed as 3 raised to power 4, where 3 is the base, 4 is the index. Now 3 raised to 4 in the multiplication form is expressed as 3 into 3 into 3 into 3. That is 3 is multiplied by itself 4 times as the power is 4. So the value will be 3 into 3 is 9, 9 into 3 is 27, 27 into 3 is 81. Sub question 2, 16 raised to 3. Dear children, this question you can solve yourself as homework. Let's go for sub question 3. We have been given base as -8 and index as 2. Now this can be expressed in index form as -8 raised to 2. That is -8 is the base and 2 is index. In multiplication form, it can be expressed as -8 into -8. That is -8 is multiplied by itself 2 times. Now dear children, we have a negative number raised to even power. That is -8 is negative number and 2 is an even number, so that is even power. Now whenever we have negative number raised to even power, answer will be positive. So -8 into -8 is 64. Let's go for sub question 4. 3 upon 7 into 3 upon 7 into 3 upon 7 into 3 upon 7. This is the multiplication form. That is 3 upon 7 is multiplied by itself 4 times. So in index form, this can be expressed as 3 upon 7 whole raised to 4. That is 3 upon 7 is base and 4 is index. Let's see sub question 5. We have -13 raised to 4. -13 is nothing but it is base and 4 is index. In multiplication form, -13 will be multiplied by itself 4 times. So it can be expressed as -13 into -13 into -13 into -13. Now dear children, observe we have a negative number, that is -13 raised to power 4, that is even power. So you can see negative number raised to even power, answer will be always a positive number. Negative number raised to even power, answer will be always positive number. So the answer here will be 28,561. Dear children, let's understand the laws of indices. First law, if a is a rational number and m and n are positive integers, then a raised to m into a raised to n is equals to, let's see what will be the answer. Now dear children, a raised to m into a raised to n, we can see we have numbers where base is common, base is a, and they are expressed in the form of product. Now let's take an example to understand this law. 2 raised to 3, that is 2 cube into 2 square. Let's see what will be the answer. Now in multiplication form, 2 cube can be written as 2 into 2 into 2, and 2 square can be written as 2 into 2. Now let's count how many 2's we have. That is, 2 is multiplied by itself how many times? Let's count. 1, 2, 3, 4, 5. So this can be expressed in index form as 2 raised to 5. Now we can write this as, therefore 2 cube into 2 square is equals to 2 raised to 5. Now dear children, just observe how we got power as 5 in the answer. So in the multiplication form, if we add the powers, that is 3 and 2, if these powers are added, so 3 plus 2 will be 5. So a raised to m into a raised to n similarly can be written as a raised to m plus n. So the law becomes a raised to m into a raised to n is equals to a raised to m plus n. Let's see the next law. If a is a non-zero rational number and m and n are positive integers and m is greater than n, then a raised to m divided by a raised to n is equals to, let's see what will be this law. Let's understand it with the help of an example. Same example what we had taken for the multiplication rule. Same example, just multiplication is replaced with division. So we have 2 cube divided by 2 square. Now this can be expressed as 2 cube upon 2 square. Now 2 cube can be written as 2 into 2 into 2, and denominator 2 square can be written as 2 into 2. Now as it is in the form of division, so the numbers which are same can be cancelled, or we can do the reduction. 2 ones are 2 ones are 2 ones are 2 ones are. Now what we are left with is only 2 in the numerator, so this can be written as answer is 2. Now this 2 can be expressed as 2 raised to 1 power 1. So we can write final answer as 2 cube divided by 2 square is equals to 2 raised to 1. Now just observe how can we get 1 as a power. 3 and 2 are the indices in the, so 3 minus 2 will be 1. So when it is division sign, we have to subtract. So 3 minus 2 is equals to 1. So similarly, answer will be a raised to m minus n. So a raised to m divided by a raised to n will become a raised to m minus n. Third, if a is a non-zero integer, then a raised to 0 is equals to, let's see what will be the answer for a raised to 0. Let's take an example. Now 2 raised to 0. Now any number raised to 0 means we don't have to write 2 any times. That is, 2 is not to be written. So what will be the answer? 1. That is, any number can be expressed in the form of multiplication with 1. Next, so it will be a raised to 0 is equals to 1. Next example, let's see the next law. A raised to 1 is equals to. So in example, we can take 2 raised to 1. 2 raised to 1 is 2. So any number raised to power 1 will be same number. So similarly, the law becomes a raised to 1 is equals to a. Let's see the next law. A raised to minus m, that is number raised to negative power. Let's see an example. 3 raised to minus 2 will be equals to 1 upon 3 raised to 2. That is, to remove this negative power, the number in the index form, which is in the numerator, will go to denominator. So 3 raised to minus 2 is equals to 1 upon 3 raised to 2. So similarly, a raised to minus m will be 1 upon a raised to m. Dear children, you need to write all these laws in your notebook. In this module, we are covering only 4 laws. Remaining laws will be continued in the next module. So for remaining laws, you need to leave space on the same page before you start with the new exercise, so that all the laws of indices will come on the same page. Practice set 27. Question number 1. Simplify. Sub question 2. Question is minus 11 raised to 5 into minus 11 raised to power 2. Now, dear children, you need to observe the question and you need to decide which law of indices will be applicable to solve the sum. Now, you can observe the base of both the indices is same. That is, base is minus 11. And the powers are different, and in between we can see multiplication sign. So whenever we have multiplication sign, powers will be, yes, added. So the next step will be minus 11 raised to 5 plus 2. So the law of indices which is applicable in this is a raised to m into a raised to n is equals to a raised to m plus n. Next step, let's solve it. 5 plus 2 is 7. So the answer is minus 11 raised to 7. So the question is simplified. So we need to stop here. Let's go to the next sum. Sub question 3. 6 upon 7 raised to power 3 into 6 upon 7 raised to power 5. Now, dear children, you can observe the base of both the numbers expressed in index form is same. That is 6 upon 7. Base is same, and in between we can see multiplication sign. So the powers will be added. Let's go to the next step. So 6 upon 7 base we will write one time, and the powers will be added. That is 3 plus 5. Law of indices applicable is a raised to m into a raised to n is equals to a raised to m plus n. That is, in between we have multiplication sign, so the powers will be added. 3 plus 5 is 8. So the answer will be 6 upon 7 raised to 8. Let's go to the next question. Sub question 6. We have p upon 5, the whole cube. Now dear children, power is 3. Whenever power is 3, it is pronounced as cube. So p upon 5, the whole cube into p upon 5 raised to 7. Now let's observe the question and decide which law of indices will be applicable. Now you can observe p upon 5 is the common base, and in between we have multiplication sign. So the law of indices which will be applicable is a raised to m into a raised to n is equals to a raised to m plus n. Let's solve the sum. P upon 5 is the base. Powers will be added, so 3 plus 7, so it becomes p upon 5 raised to 3 plus 7. Let's write the law of indices as a reason. So a raised to m into a raised to n is equals to a raised to m plus n. P upon 5 raised to 10, that is 3 plus 7 is 10. So we got the answer. Practice set 28, question number 1. Simplify. Sub question 1. A raised to 6 divided by a raised to 4. Now dear children, you can see we have two numbers in the index form, that is a raised to 6 and a raised to 4, where we can observe base is common and in between we have divide sign. So we can apply law, that is a raised to m divided by a raised to n is equals to a raised to m minus n. So the powers will be subtracted. So we can write the next step, that is a raised to 6 minus 4, a raised to m divided by a raised to n is equals to a raised to m minus n, can be written as a reason. Now dear children, tell me 6 minus 4 is 2. So we get the answer a square. We can write the final answer as, therefore a raised to 6 divided by a raised to 4 is equals to a square. Please see that you write final answer in all the sums. Sub question 3, we have p cube divided by p raised to 13. Here also we can observe both the numbers in the index form have same base, and in between we have divide sign, so powers will be subtracted. So we can write the next step is equals to p raised to 3 minus 13. Now 3 minus 13 will be minus 10. Now let's first write the reason, that is a raised to m divided by a raised to n is equals to a raised to m minus n. Now 3 minus 13 is minus 10, so we get the answer as p raised to minus 10. Now, please see that we convert this negative power into the positive. So we can apply the law, that is a raised to minus m is equals to 1 upon a raised to m. So it will become 1 upon p raised to 10. Reason, a raised to minus m is equals to 1 upon a raised to m. We can write the final answer, therefore p cube divided by p raised to 13 is equals to 1 upon p raised to 10. Question number 2, find the value. Now in this question, first we will simplify the question After simplification, we will find the value. Let's see how. Sub question 1, we have minus 7 raised to 12 divided by minus 7 raised to 12. Now we can see both the numbers in the index form have same base. In between we have divide sign, so we can subtract the powers. So next step, minus 7 raised to 12 minus 12. So 12 minus 12 is 0. Let's first write the reason. A raised to m divided by a raised to n is equals to a raised to m minus n. Now 12 minus 12 is 0. So we get answer as minus 7 raised to 0. Now we already know any number raised to power 0, answer will be 1. So we can write final answer as 1. Law applicable is a raised to 0 is equals to 1. Let's go to the next sub question 3. 4 upon 5 the whole cube divided by 4 upon 5 the whole square. So we have two numbers in the index form where base is in the form of fraction, that is 4 upon 5, and in between we have divide sign, so we are going to subtract the powers. So we can write the next step as 4 upon 5 raised to 3 minus 2. Now the law which is applicable is a raised to m divided by a raised to n is equals to a raised to m minus n. 3 minus 2 is 1. Now any number raised to power 1, we get that same number. So 4 upon 5 raised to 1 will be 4 upon 5. Now dear children, you need to write the laws of indices first. At the start of the chapter, we have covered 4 laws in this module. Remaining laws of indices will be covered in the next module. So for the laws which we'll be learning in the next module, you need to leave space for writing those laws so that you can continue those laws on the same page. And you need to solve practice set 26, 27, 28. Thank you. I hope you understood all the sums.